Suresh Babu sir, welcome you sir. I'm happy to welcome all the participants for the Atal sponsored 6-day online FDP on recent advancement and challenges in integration of IoT and 5G and 6G wireless communication, building the next gen connectivity. I welcome all the participants. So, participants' kind attention. Uh, Participants are requested to check their attendance from the Atal portal. So, participants are asked to maintain the 80 percentage of attendance. And another one instruction from the coordinator side. Um, Very few participants are only send their NOCs to the mail ID. So participants are requested to send all the participants are requested to send the NOC to the mail ID.
Welcome, you Suresh Babu sir. Shall we start, sir?
Yeah, I'm ready. Hello.
Yes, sir, you are audible, sir.
I'm ready.
For today's session on a blockchain technology for secure transaction in 5G network. For that, I would like to welcome Dr. Eric plus Suresh Babu, sir, Assistant Professor, Department of ECE, National Institute of Technology, Varangal. It's my pleasure to introduce our speaker, Dr. Erikula Suresh Babu. He is an assistant professor in Department of Computer Science and Engineering at National Institute of Technology, Varangal. Dr. Suresh Babu has more than 21 years of teaching and research experience. He completed his Bachelor's of Technology in Computer Science and Engineering from the Jawaharlal Nehru Technological University, Hyderabad, in the year of 2003. His Master's in Computer Science and Engineering from Visvesvara Technological University in the year 2007 and obtained his doctorate from Jawaharlal Nehru Technological University, Kakinada in 2017. He has received more than 58 lakhs in research fundings for various research projects. He has published 53 journal articles.
Hello. Hello. Hello, may I am audible?
Yes, sir, it's audible.
Okay, I think should I start? I don't know because the voice is not coming from the Yura sir.
Hello, sir.
Yeah, Yura sir. Yeah, shall I start the session?
Yes, sir. We can start the session, sir. So before that, we have a photographic session, sir. So, resource person and participants are asked to turn on their camera for the photographic session. Sir, can you please stop the presentation so that we can take the photos of the participants? Okay, sir. Thank you, sir. Participants are requested to turn off their cameras. All the participants are requested to turn off their camera.
Shall I start now?
So before going into the session, okay, so you can start this, sir.
Yeah, please
So
go
you
ahead.
can
Please
start.
go ahead. Please go ahead. No problem.
Yes, sir, your screen is visible, sir.
Shall I start?
Yes, sir, we can start, sir.
My PPT is visible to all the participants.
Yes, sir.
Yeah. Very good evening to all of you. Uh, First of all, I need to thank the coordinators for inviting me to give this invited talk on this Atal FDP program on next generation technology. Today, I'm going to deliver a talk on blockchain in 5G enabled IoT network. So, which is very interesting area, and a lot of research scope is there in this area. Now, before I start this session, let me ask a few questions to the participants. The first point which I want to ask is whether the participants are related to which background?
Sir, all the participants are faculties and research scholars, sir.
No, faculty of computer science or electronics and communication?
Sir, electronics and communication, and
Majority.
yes, sir, major participants are from electronics and communication, sir.
Oh, good, good. Yeah, yeah. So because that's a point we need to see how. Right. Now, there are very interesting aspects that we need to concentrate. When we talk about this. All right. There are a few interesting aspects for there. IoT networks, which is not new, which we'll try to discuss in detail about this IoT networks. Then the role of 5G in IoT network, and then the role of the blockchain in 5G enabled IoT network. We'll try to discuss in detail about this one. Before I start the session, let me see, because maybe this uh, fifth or sixth day, I don't know if I'm correct, sixth day. What are the various trends and technologies you come across? Various next generation technologies which we are going to come across. Now, if you observe here carefully, the next generation digital transformation, especially with respect to the industry, we are talking about the digitalization, digital transformation, which we are going to call it as. Right, things will be an important things will be there. Then the humans will come into the picture, which you are talking about. Then environment, the different types of environment, because the IoT is the one technology where it will bring the humans and the nature together. There's only one technology where we can make it a good relationship between the environment and the humans. Right. So whatever we are talking about, there is a dynamic data generation which is going to be happen, and it should be flowed as a network based. So currently we can use either 4G or 4G LTE, or we are going for the 5G network, which is a network based, and then we are going to create an intelligent system here, and then we are talking about the various applications like smart analysis, smart decision making, smart operations, as well as a smart optimization, which is going to be in the as a part of the digital transformation. Now, in order to achieve these digital transformations of industry, there are multiple technologies, distinctive technologies are there in the fourth industrial revolution. First one is a cloud. Thanks to this technology, because we talk about with respect to the cloud, now the cloud is act as a mainstream technology. This has been there from last decade as a mainstream technology, and the major aspects of this cloud is IT sector, information technology sector, which we are right. All the IT sector information which we are going to store onto the cloud. The next part which we are going to talk about the fog computing or edge computing, right? Which we are going to discuss very interesting aspects of this, which is going to play an important role in the 5G network, is a fog intelligence or fog computing, right? Where the processing will be done at the edge level itself, or intelligence will be done at the network level itself, right? Before we go to the core network, we are going to perform at the edge level itself. The next very interesting aspect that we need to concentrate is IoT, Internet of Things, which you're going to have it. The future is all about what? Intelligent Internet of Things that we can have, or intelligent Internet with intelligent things, or Internet of Intelligent Things, which we can have. So the combinations which we can see, different types of technologies that are going to come into the future as the industrial fifth revolution, which we are talking. The next one is the cyber security, the success of cloud, or success of fog, or success of IoT. It depends upon the cyber security. Then, as I already told you, right, one of the key aspect of that, if I want to make it intelligent things, if I want to connect different types of things, the 5G is going to play an important role. Uh, so, the 5G is going to play as a service technology to the IoT. And then big data, we need to concentrate big data with respect to the IoT, as well as because we need to concentrate on the operational technology which are coming from the various cyber physical devices. And then additive manufacturing as well as the blockchain. So these are some of the disruptive technologies of the fourth industrial revolution which you are talking. Whether my voice is clear?
Yes, sir.
Yeah. Thank you. Now, we try to concentrate in today's session 5G, Internet of Things, fog, and then the role of cybersecurity and the blockchain, which are the servicing technologies for these networks which we can have. So these are the three interesting aspects that we need to concentrate. Right. Now, before I go into this, because already maybe some of the resource persons are experts, they already covered IoT. You have come across this Bluetooth, all of you? Bluetooth? let's make this session as more interactive way, right?
Yes, sir.
Now, Bluetooth is a infrastructure network or infrastructureless network?
Infrastructure-less network.
Very good. Infrastructureless network. Very good. Right. It is an infrastructureless wireless network. Right. So, which is called as a single hop network. Single hop network which we're going to have. Now, thanks to this technology, because this is going to rule the world which in future by using this, right, the next generation BLE, we call them as what? Bluetooth low energy, right, where large number of devices can be connected with the, along with the sensors, along with the RFID tags with the BLE. And then along with that, the smartphone apps is going to relate to the industry 4.0. Now, these things can be integrated in larger things, it can be integrated in smaller things, or it can be a small to a tiny things can be there, right? It can be varied from larger things to the tiny things. Now, when we observe carefully, from last 6 years, there is a tremendous growth of is there in the information technology from mainframe computers to network and distributed computing. We go for, right, we require, because what is a challenge now for the next generation faculty is, especially, they need to have a multi-domain experts. Now, suppose for example, if you are good in ECE, yes, you can survive, but you should have expertism in right CSC. You should have some expertism in EEE. You should have some applications known to be in civil department. So therefore, multi-domain experts we require. As a teacher, we should have some knowledge on these things, because if we take IoT, we can say IoT it is not related to ECE or not related to CSE. It is not related. So it's a combination of multi-domain, interdisciplinary course. It is Internet of Things, right? If ECE is going to handle, they concentrate morely on the hardware level. If CSE people handle the IoT, they concentrate on edge intelligence, MLAI, cloud intelligence. They concentrate on networking aspects. So if IoT need to be taught as interdisciplinary, you should have the concepts of both hardware level as well as the software. That is very important aspect that we need to concentrate. So why this multi technology integration is required in the sense, because industrial IoT requires the multi technologies integration. Right. So therefore, these are the industrial IoT supporting technologies. The first one, which I already told you, the cloud computing. Then we are talking about edge and fog computing or mobile edge computing. And then we are talking about SDN networks, software-defined networks, and we are talking about what NFV, network function virtualization. And then the very important aspect that we need to concentrate, where your FDP is all about this for next generation technology like 4G LTE, 4G LTE, advanced Wi-Fi, or advanced Wi-Fi, which you can have it, and then 5G. So these are the various advances in wireless technology, which need to handle not only the IT sector data, but also we need to concentrate on the operational technology, which are coming from the unknown sources, operations. And then we need to talk about data technology, PT, and then core technology. These are some of the core technologies which we are going to talk about, core technologies which we have. So therefore, there is an interesting aspects out there on IT, OT, BT, as well as the communication for core technology. Now, if you observe carefully here, because IoT, Internet of Things, are new computation paradigm which we are going to have it. Now, usually, what we are going to, we have the edge devices or edge networks. Directly, all these edge networks are going to be able to store at the cloud data centers. Then, because what is a major problem? Can anyone tell me what is the problem with these type of networks? You understood my question? When the edge devices or edge networks are connected to the cloud, What are the challenges we have? That's my question.
Synchronization, sir.
Oh, right. Okay, synchronization.
Uh,
So data security.
Okay, data security. That's one of the challenge we
time
have.
latency, sir.
Very good. Latency is a big challenge we have. Next, good answer that we can have. See, the major challenge which we are talking about, these devices are edge devices, and then when we are
Data
connected to
data cleaning.
data cleaning, okay, good, good, because data cleaning will be happening here, madam, I think, isn't it? See, the major challenge which we are talking about is when these fellows, like for example, now I am there, like I'm going to dump the data to all the participants. Now, few people will recognize my data, few people will understand, few people they will feel this topic is not relevant to me. They will overflow. They will not concentrate. So, what is happening here? See, whatever the data which is coming from the edge devices, latency problems will be there. Transportation cost will be increasing. Transportation cost will be increasing. Suppose, for example, you see if my session is not good, then it's a wastage of bandwidth. If few people are traveling on right, you're going to listen the lecture on travel, and if this lecture is not good enough, so wastage of bandwidth also. Transportation cost will be increasing. Why should I waste all the data what we are going to store onto the cloud? So the major problem we have is transportation cost. The data which is coming much faster rate, whether cloud is able to handle that data. Latency is a big challenge we have. So people will start introducing the concept of what? Of fog computing. This is the word called fog, which you are talking about. Means before I send to the cloud network, I'm going to process some data here itself. Then I'll send to the core network. So that's a point which we need to talk about that. Right. So therefore, there is a edge network, edge network we have, fog network, to core network, and data center network, cloud network we get. So this is the way how the fog is going to play an important role where the processing can be done at the edge level itself. Then this is the edge computing where we can process the data at the edge devices itself. I need not to send it to the cloud level. Then mobile, all the mobile will be directly connected to the cloud level. Then mobile edge computing where the processing will be done at the edge servers itself. So these are the various types of computing paradigms is required in the IoT computing world. You are going to follow me?
Yes, sir.
Yeah, thank you. Now we are going to talk about the very interesting one called intelligent connections. Please understand carefully. We are going towards this 5G network. The 5G network is all about what? Connectivity. 4G is all about what? Broadband. Right? So when we talk about what in future we require intelligent connection of people, process, data, and thing. We also call as network connection of people, process, data, and thing, where it is a combination of IoT, Internet of Things, that is going to connect even without the human being. That's a main genesis of IoT which we are talking about. Right? So how to establish these connections and how to establish intelligent connections. So therefore, we need to we need a lot of research scope is there with the genesis of IoT. Right. So the future innovation is all about what? The cloud, the IoT, big data, and AI will be the future innovation. Now, if you observe from last 4 years, there is a tremendous growth data generated in like in 2020 itself, it is already 44 zettabytes of the data, and it has been increased to 76 zettabytes of the data in 2023 last quarter. So huge, enormous data generation has been happening. And if you already observed, right, in 2013 itself, the people are already behind the devices. And more number of devices are already connected to the internet. More number of IoT devices are already connected to the internet. So the future innovation is all about having how to apply these disruptive technologies to make it more robust. right? IoT concept is already covered by other resource persons. If it is already covered, then I'll skip these slides.
Yes, sir.
It's already covered. I'm correct?
Yes, sir. Yes,
Yeah,
sir. It is already covered, sir.
yeah, right. Thank you. Now we are going to talk about the very interesting one, as already I told you, that we are going to call this Internet of Everything, where I already told you is the internet intelligent connection of the people, process, data, and things. Data and things. Therefore, we are going to see that IoT, it's also called as Internet of Everything. So that what is the main service that this Internet of Everything is going to provide to us? The right information will be available to the right person at right time. Right information will be available to the right person at the right time. So that's the main purpose of intelligent connection of people, process, data, and everything. So here the things are smart things. In future, it will be intelligent things also, where we need these things will generate the data, and we need to convert that data into more understandable information, and the process whatever we are going to achieve, so that information, the right information to the right person, and people will be collaborating to make the decision making. So we can make use of this internet of everything as the people, the process, the data, as well as the things. Okay, so the next very important aspect that we need to concentrate, you take any IoT platform, it can be IBM Watson, it can be AWS Azure IoT, or it can be Siemens Mindsphere, whatever may be the platform we can have, right? Those, all the platforms need to support these 5 metrics, we can say, key requirements, because IoT is known for intelligent and dynamic in nature. And IoT, because the inherited property of IoT is internet, which is distributed and decentralized, and it scales large number of devices, and the IoT is going to handle the real-time data which we are talking about, right? And then we need to concentrate the key requirement for any IoT platform is the security and the privacy. So therefore, these are the key requirements, but most essential and recommendable requirement is security and the privacy is a key requirement that we need to address. Okay. So we can say the success of IoT is depends upon 6 important metrics. The first one is the trust. The second one is the identity. The third one is the privacy. The fourth one is the protection. Fifth one is the safety, and then sixth one is the security. Right? This is not in our case. Protection and the safety is not in the case. As a manufacturer, they need to take care of that. The other part of that, the trust need to be built. Identity of the devices, when million devices are going to connect it to the internet, and whatever services they are going to provide it. So that identity is a very important aspect that we need to. The second one is the privacy issues. So to make it every device a personal sensitive data to keep the private. And then we are going to talk about the security aspect that we need to have, maintain the security of the data, devices, and people need to be ensured. So the success of IoT is depends upon 6 important parameters. The one is the trust, second one is the identity, third one is the privacy, fourth one is the security aspect. So these 4 important metrics that these are the key metrics, key challenges any researcher can work on these key challenges. Do you have any doubts up to this?
No, sir.
Yeah. Now we need to talk about what is the role of 5G in IoT. That's a very important part that we need to have. Yes, no doubt. IoT is going to provide a very important service, which is very important anywhere, anyhow, I want to get the data. That's a major service that IoT is going to provide it. What is the role of 5G in IoT? That we'll try to discuss. Now, we know that because already maybe you have come across the 5G is a next generation technology. Okay. This is called as an next generation learning. Right. Right, the 5G is a fifth generation with the wireless network technology. The first key characteristic or feature is high-speed internet. This is a very, I think you already come across this 5G network and 5G communication by the experts. Then the very interesting aspect again, it's an ultra low latency, hardly approximately milliseconds. Then the very important characteristics for IG is massive connectivity, means large number of devices. Already I told you in 2020, 50 billion devices are already connected to the internet. Right? Massive connectivity. Now in 2024, if you observe carefully, right, 84 billion devices are already connected to the internet. So massive connectivity of IoT devices. And then the very important aspect that we can have it, though it is a challenge, but it is also a service. Energy efficiency. Energy efficient mechanisms have been incorporated in the 5G. Now, if you observe carefully, it is not an upgrade from 4G to 5G. It is a paradigm shift for new technology and its innovation. Now, already we know that evolution, 1G is known for voice, 2G is known for text, 3G is known for internet, 4G is known for broadband, and 5G is known for connectivity which are more suitable for the IoT devices. Okay. Now, what are the key components in 5G network? Just to have a recall, we have a radio access network, RAN. These are the edge devices. These are the edge devices, or we can call them as user equipment devices. We can have, right? And then we are going to have the core network. This can be a core network. At the edge, this is the one of the core network at this level. This also mobile core can be happening here, right? Where the processing, edge processing can be done here, right? Edge computing can be done. That's why processing data closer to the edge devices for low latency. Where IoT requires, because IoT are known for, IoT devices are require a low latency, and it's going to provide a better solutions to us. So all the devices we talk about, it can be a smart device, it can be IoT device, or it can be autonomous vehicles, or ranging from small devices to gain missions. All are comes under the IoT devices, right? So when we talk about that, these are the key components that 5G network is very, very essential. I'm going to concentrate more on the edge computing in IoT, and then the security parameters in the IoT network. Now, these are some of the applications where the industry has been looking, where we can apply in smart cities. 5G is going to play an important role in real-time monitoring, traffic management. We can have it. Healthcare sector, which is going to play an important role. Autonomous vehicles, vehicle-to-vehicle communication. In entertainment, already you people are right. Easy people know much better because the 4K and 8K streaming, which you're going to have it from HD to 4K and 8K streaming has been experienced much better streaming. And then we are going to have manufacturing sector, which is going to be n number of applications we can use because if IoT is going to provide solution that IoT requires this 5G as a 5G network to provide the better solutions. Then what are the key challenges we have in the 5G network? The first and primary most thing, as we know that, is a high deployment cost. Building 5G infrastructure includes a lot of base stations need to be set up, fiber networks need to be replaced, antennas need to be there, which are very, very, very expensive. Infrastructure complexity within that, because it is a dense network, it is a distributed network we can have with the smaller cells, which we can have. The third and very important one, because large number of devices are going to be connected, so there is a chance of cyber attacks is going to happen. Any unauthenticated device is connected to the internet. And from there, these botnet attacks are going to be happening. And then the legacy with the existing systems, because when you want to integrate the 5G with all the 4G, the compatibility issues will be right, which we're going to have. Now, most of our mobiles, which are not going to support 5G, right? Very recently, if you have taken 1 year back, it may support, but if you've taken 3 years back, the 5G is not going to be support. Compatibility will not be there. And limited device support will be there, right? With a high cost and limited availability of the 5G compatible devices. But we are going to concentrate specific to the security. Now, if you see expanded surface attack, I'll give an example. Just you have seen the Rajinikanth movie Robo, Part 1 and Part 2. Whether I'm audible?
Yes,
Hello?
sir. Yes, sir. Just
Yeah.
audible.
Okay. So if you observe here, every connected device can be a potential entry point for the hackers, which you can have. And then you observe, then if you see Rajinikanth movie, there is a concept called botheads. Right, a master robot will create the slave robots, and then a botnet can be created, which is a distributed denial of service attacks. Right, 5G is, I mean, because 5G connectivity helps the IoT devices. At the same time, it can lead to various attacks like DDoS attacks, man in the middle attack. And then the other important aspect is location tracking and privacy concern. If you observe, most of your Google is going to track you every time, right? If you have enabled, if you have disabled your privacy, then it will track it will track your current location, and it will tell you after 2 days, right? You are in this position, you are in this place, you are in this place. So location tracking and privacy concern will be there every day. It's like a eagle; everything will be monitoring, right? Rogue base stations, malicious base stations, and spoofing can be happen. Edge computing tasks, because most of the 5G networks are enabled with 5G edge computing, and then these devices are limited security, and it can lead to the malicious attacks at the edge level. Then AI, because we are going to apply a lot of AI algorithms on IoT network. AI powered attacks can be adapted in real time to bypass any conventional or traditional security measures. And the major challenge that we are going to concentrate is lack of end-to-end encryption, which we're going to talk about. Lack of end-to-end encryption. So some of the mitigated strategies is required for the 5G and IoT network. We need to provide a strong encryption technique, which we are talking about. How to provide a strong end-to-end encryption? Because if you observe carefully, we have the edge devices and we have the cloud, and then we are going to have the core network. Your core network can be a 5G network. Now, how to provide right end-to-end encryption from these edge devices to the cloud network, which we are talking about. Right. So securing IoT devices, definitely it is a big challenge. End to end is going to happen. And then we are going to apply a lot of AI algorithms for detection. Unfortunately, the attacks on AI can be happen because we are going to provide attack detection, threat detection using AI. But attacks on AI, how to solve the problems? Then the major we can see user awareness. We need to educate the users to identify phishing, because without lack of awareness, the attacks are going to be happen here, right? A lot of things. So identifying the phishing, spoofing, and other common threats which are going to be happen. So these are some of the mitigation strategies need to be employed in IoT network or in 5G enabled IoT network. Okay. We'll try to see now. Do you have any doubts?
Dear participant, do you have any more queries? Means you can ask doubts to the resource person. Sir is waiting for your queries.
No. Okay. I think they have responded. No, no, sir. Yeah. Thank you. Yeah, you can unmute and you can ask if you have any question. Sir, they are unable to unmute here.
Sir, now we will provide the permission for them to mute themselves, sir, unmute themselves, sir.
Yeah, yeah, please.
Now the permission has been granted, sir.
Yeah, yeah.
So we can carry on the session, sir. At the end of the session, they will ask the queries. I think
Oh,
so.
at the end. Okay. Because maybe okay. If they are asking at the end, you see, they can have dynamically if they want, they can have it. No problem. Okay. Anyway, I'll. Now, when we talk about, say, there are multiple things were there here, right? IoT is not a single technology, which I used to say. It's a technology integrator, right? We are going to talk about what the wireless sensor network will be there, right? And then non-IP networks, non-IP networks, which you are talking about. Then IP network, which you are talking. Next one is where your 5G or 4G will come into the picture, right? Which then we are going to talk about the fog computing. We are going to talk about the edge computing. We are talking about cloud networks, right? We are talking about big data. So therefore, the other name for the IoT is a technology integrator. It will integrate multiple technologies. So to design such a complex IoT architecture, such a complex IoT network, we require we require a proper architecture, a proper hybrid architecture. So therefore, we are going to see one. There are so many architectures are there in the literature, which we are going to have it. We're going to discuss one literature, one model called IoT World Forum Reference Model, or IWF reference model, which is a 7-level model. This is a 7-level model. The where we are going to talk about here. Here there is the role of the physical devices and controllers. We can have different types of IoT devices will come here of different nature, right? Again, here we could have non-IP network, which comes under the short-range communication, non-IP networks. Again, this will be here. We are going to talk about what connectivity, which we are talking about. Again, the connectivity will be right, long range communication as well as short range communication, which we are talking about. The connectivity can be happening. And then the role of fog computing, as already told you, the fog computing where it will perform a data element analysis to convert that raw data into more understandable information. And then we are going to talk about cloud computing where the data will be residing. Data abstraction, we need to keep data ready to the end users, and then applications can be used for reporting, analyzing, and as well as the controlling the data. Now this part which we are going to talk about is, we are going to call them as what? OT part, operational technology, OT part. And this part which we are talking about is the IT part, IT. Now, this part which you are talking about is the real-time data, and data in motion will be in travel. We are going to convert into data at rest. Data at rest. And this is a real-time data. We are converting into a non-real-time data because we're going to store into the cloud. Now, because the OT, this is the IT sector part plus OT sector part, which we can call them as the IoT sector, OT and IT, which is because that's why we are going to see now. Up to now, we concentrate on IoT devices connecting to the cloud. Now what we're going to do is IoT devices are going to connect it to the fog network, and fog networks will be connected to the cloud networks, which we can do have, right? So that's where we can have it. Now this way, which we, as I already told you, that these are the IoT devices. As you already know the IoT code, therefore I skipped those slides. And connectivity, fog computing, cloud computing, data aggregation and abstraction, as well as the reporting, analytics and control. Now, if you observe here carefully, right, which you could have the process layer, as already told you, internet connection of people, process, data, and a thing. The process which you are talking about is that this is the process layer we can have. This is the right local area connectivity we can have, and this is a wide area connectivity, which is a part of the 5G network, and it will have both the edge computing as well as the edge devices, right, which are going to be connected to the cloud. Right? So therefore, we can say a 5G enabled IoT network. Now, quickly we'll try to see with an example of IWF reference model. Right? We have the edge devices of heterogeneity of different heterogeneity devices. Then that will go to the network connectivity where it will send and receive the data from the IoT devices, and then we are going to process the data where we are going to filter the data, we are going to normalize the data, we are going to store only fine-grained data, at the edge level, and then we are going to send it to the data cloud, cloud storage, we can call it as, right, where it will be stored at rest, and then we'll process the data by using the data abstraction, and then it will be used by the applications which are accessed by the applications, and then people will be collaborating. So this IWF model will give a lot of clarity, and then it will give how to, if you want to implement it, this IWF model will give a lot of features, and you can apply this IWF model in your research work also. I'll give in detail how we want to design a network. You can see this is one network. We can call them as edge network or IoT network. And then the gateways will be there. We call them, the gateways can be used, make use of the fog devices, which we can have. And then we can use this 5G enabled network connectivity, which we can use, which uses both non-IP network as well as the IP network, which we are talking about. And then we are talking about is the cloud infrastructure. There is a cloud infrastructure which we are going to talk about. Right? And then finally, people will be used for different applications. So if you observe here carefully, that IWF model will give the clarity. It requires a hybrid architecture starting from the edge devices to the cloud applications we can have. Right. Now, before I go into the blockchain, first of all, we need to implement, right, we need to understand what is the role of the edge computing and fog computing in 5G enabled IoT network we can have. Right. So, when we talk about this one, we are talking about this one, the role of edge computing and fog computing. Now, we have concentrated the whole lecture of 1 hour. No? Now, can anyone tell me what is the role of edge computing in IoT? What is the need of this edge computing in IoT?
To remove the unwanted data.
Okay. Okay, very good, madam. So to remove unnecessary data, isn't it? Unnecessary data or fine-grained data, to push it to the fine-grained data. Okay, that's a good one. Any other?
அதாவது ஒரு துளி கூட அவன் இனிப்பு சாப்பிடக்கூடாதுன்றாங்க.
To reduce data processing time.
Yeah, to reduce the latency.
Yes,
That's the
yes.
point we need to have it to reduce the transportation cost. When we talk about redundancy, transportation cost will be reasonable. So if I'm sending 100 data, 100 redundant data, I'm going to send only one data on behalf of that one. So therefore, the traditional IoT IT computing architecture, we have an endpoint. It can be a 4G network, doesn't matter. It's a core network, or 5G, doesn't matter. And then cloud, we are going to push everything onto the cloud. So the load on the core network will be very, very, very high, and the scalability issues will come into the picture. Right? That's a problem with the traditional IT computing as well as the architecture. Now, because we are going to push everything onto the cloud, and then we are going to do the processing at the cloud level. This is the traditional way of IT processing need to be done. So how to overcome this problem in IoT in this sense? Because the major challenge which we are talking about, as I already told you, too much of latency. Transportation cost is too high, as I already told you. Practical resiliency is difficult to achieve, and too much of data which is coming from the IoT data, because it's not IT data. IT data is known data, whereas IoT data is unknown data, a real-time data which is coming from the IoT devices. We don't know what type of data it is going to come. So there are little bit challenges were there which need to be solved at the cloud level, which you can say. For that, what we need to have it, because unfortunately, IoT applications require very shorter response time, and most of the data is a private data, and some might produce a large quantity of data where heavy load will be there on the network. Suppose, for example, you take it autonomous vehicle. Autonomous vehicle per hour, it is going to generate 100 GB of data. 100 GB of data will be generating. If I want to push 100 GB of data onto the cloud, which is not a practical solution, it's going to generate a large volume of data, heavy load, which is going to be connected to the cloud. So therefore, it is not possible to store. We need to process the data at the edge level itself. That's a major challenge between, because this autonomous vehicle is an IoT device. So that's why huge volume of data at the data center is very, very difficult to have it. Everything we are going to push onto the cloud. It can be IP surveillance cameras. We can have any IoT devices which we are going to. So overload the networks and with the data centers. So major challenge is nothing but what? Devices are going to generate the data much faster than IT. And it is very difficult to perform the real-time feedback and data analysis at the cloud. Right, up to now, whatever we talk about, whatever we are going to discuss, these are all IT data, and real-time feedback analysis can be done because it's a known data. Whereas IoT is the unknown data, and as a real-time data, we don't know what type of data it is coming. So real-time feedback analysis is a very, very, very challenging we are going to have. Right? Some feedback mechanism is a must. So therefore, the role of cloud, big data, and AI is a very, very important in IoT. As I already told you this concept to you, right? Which we are talking about. See here, if you take any applications which you are talking about, now currently this is a process which is happening. Now what we have reduced, right? A smartphone to the edge network to core network, we're going to have it. And then this is the third way which we can have it. So this is the edge resource networks and core network. So a very interesting network which we're going to talk about here, which we're going to, IoT computing is required, such a mechanism. Now you see, right, this is an IoT device. We are going to do first level of processing. We call them as the edge computing. We'll do one more level of processing. We call them as a fog computing. All right. Right? And we'll do one level of processing called a cloud computing. So we can go for IoT requires new. What is the advantage here? Right? We are sending the data at the cloud level for processing. Now we take the processing to the data level itself. So that's the beauty of IoT computing, which we need to have. So processing need to be done at the edge level itself. That's why we make use of edge computing or fog computing. Clear? You're able to follow me?
I can't add.
Yes, sir.
Yes, sir.
Yeah. So this is a way which we're going to see here. Now the IoT data is a big data which you are going to do. It's a large volume of data which is coming from the IoT devices. We process it, we convert into refined data, and then this data is a small and fine-grained data, intelligent data. Before we store it to the cloud, we can have. Then a backend, cloud-to-cloud backend data sharing can be happen in future. Right. What is the meaning of that? Actually, usually that IoT communication model, it's a device-to-device communication, device to fog communication, fog to fog communication, fog to cloud communication. Communication need to be happen at these levels. Right? Currently, device to cloud only we are talking about. So indirectly, we require this type of communication models need to be ensured. Right. Now, what is the role of the blockchain that is going to drive the various technologies? I think anyone heard about, come across this blockchain in participant? You come across? You have an idea?
Sir, we heard about it, sir.
Okay.
So,
Right. Anyway, no problem. So, see, just I'm asking a few questions in the sense to make it more interactive. That's the only point, my point of concern. Because if you're answering, you will be more active. Otherwise, the human tendency is from morning 9 to 5, you're already busy with your academics, and you may be taking the class, you have labs, and then when you're going home and sitting these lectures. For me, right, I can take 1.5 hours or 2 hours, doesn't matter for it. But receiving side, that's I already told you, you are like a cloud. I'm like a sensors, IoT sensors. I can dump the data. But at the end of the day, if the cloud is unable to respond it, feedback, whether I'm sending it data, whether it is correct or not, that's a challenge. So a question answer definitely will give a lot of clarity what level you're able to follow me so that I can go in detail or I can go only abstract way. So that's a point I'm asking the questions. Don't mind because you are faculty members. Now we are going to see how the blockchain is going to drive the various technologies we can have. So there is a close relationship is there between the 5G and a blockchain. 5G is a distributed network. Blockchain is also a distributed system. When we are connecting large number of IoT devices to the 5G, right? The success of 5G depends upon its security and privacy. Right? Why can't we apply a decentralized system, a distributed system to protect the 5G network? That's a area. Then, because the blockchain was designed by taking the security parameters into the consideration, cybersecurity parameters into the consideration, say, cybersecurity features were there. So there is a close relationship is there between the cybersecurity and the blockchain. And then when we are talking about big data, because data leakage can be happen at this level. So how to ensure the security features, right, between the big data as well as the blockchain? How to eradicate the data leakage using blockchain? And then fog computing, because these are the fog networks, which I already told you, these are the fog networks. And then we can use a blockchain, public blockchain here, where it can monitor the whole internet, can be there using the smart contract, can be built. And then even we need to talk about the smart contracts or intelligent contracts, blockchain and the machine learning, which we're talking about. So that's another area where we can concentrate because there is a close relationship is there where we can apply the AI algorithms on blockchain, and then cloud computing using blockchain can be applied, as well as vehicle to vehicle communication, vehicle network using blockchain can be used, as well as IoT using blockchain can be used. Now, if you observe carefully, what are the challenges we have in IoT? Those challenges can be solved using the blockchain. Blockchain properties or characteristics helps the IoT network in a very efficient way. So therefore, we can say definitely blockchain is going to provide the solutions of what are required for the IoT network. We'll try to see for the layer. Right? What is this blockchain is all about? We'll try to. Now, the other name for the blockchain is DLT. Now, if I share this PPT to all the participants, what is the advantage? Before I take a class, right? I'm going to share all this PPT to all the participants. What is the advantage with that? Any advantages there with when we share the PPT to all the people? Now, doesn't have any. It has any advantages there or no?
We can have some ideas or prior information about what are the topics to be covered in the.
Transparency, you mean to say. Whatever I'm covering, whether you will prepare it and you will come well advanced, is it?
Yes, sir.
Suppose if I want to skip it based upon the student, based upon the participants, if they are not responding, I'll hide certain slides and I'm unable to tell those slides. Isn't it? Manipulations is not possible. Yes or no? So, what is the advantage with have a shared means we can ensure right resilience of that one. There is no manipulation. Manipulation is highly difficult. So, distributed ledger technology, the other name for the blockchain is the information, whatever I'm passing, that is transparent to all the members. All the members. So, which we can apply as a distributed ledger technology. All the transactions, whatever we are talking about, all the transactions they are going to store in the form of a ledger. In the form of a ledger. Like, for example, if you observe here, transaction 1, transaction 2, transaction 3, this is one block. Transaction 4, transaction 5, transaction 6 is another block, right? So it's nothing but what all this block I'm going to share to all the members in the network. That's the meaning of this. Whereas this is not required, and whereas the blockchain is going to use a peer-to-peer network. Peer 1, I can send you to peer 2. Because now if I want to communicate straight away, I can communicate the person who is communicating with me, I can communicate with them. And everyone will be watching what these two people are talking. In this FDP program, if resource person along with the participants, they are communicating each other, everyone will be monitoring. That's why it is a decentralized peer-to-peer network of nodes. And then we are going to use, because I already told you, blockchain has inherited cybersecurity features, security features. We have a public key cryptography without any central authority. Right? No central authority will be there where public key cryptography will be used. And then we are going to see here, right, all the transactions. See, for example, if I want to, right, 130 participants were there, right? If I want to go to the next slide, I'll ask a question. If at least 50%, means at least 70 participants, if they answer, then only I'll go to the next slide. What is why I should use that such mechanisms? See, if I want to go to the next slide, I'll take the feedback or the input from at least 70 participants of this class. Why I require that? Out of 130 people, if only 1 or 2 are responding, right, remaining people are not responding, what is the problem with that? Why I require at least 70 participants should answer the question?
Participants, you can unmute yourself and discuss with the resource person.
No, no,
I
my
repeat
question.
again.
No, sir. This is a question only. They need not to respond it. Okay, no. Yeah, okay. They are unmuted. Yes. Okay. See, very simple to understand this. All the transactions. Now, actually, I asked one question, Q1, to all the 130 members. That's a transaction, 130 questions. Now, at least if I want to go to the next slide, I require the answer at least from 70 people. Why I require this concept here?
Because already you have shared the slides with everyone. So you are assuming that all the people have gone through the slides.
Okay. That's a good answer. Okay. Why 70% of the people need to answer?
Not 70, actually everyone should answer, but we generally expect that all have not gone through the slides. So we are okay,
In general
70%
case,
are great. That's enough. We assume like that.
yeah, very good answer. Now I'll give an answer to you, sir. Very good answer. See, already I forwarded all these slides. That's the first thing. And I asked a question, right? In a network, of 130 members, there may be malicious nodes. There may be passive participants will be there. There may not be answer, right? But I'm concentrating on active. You see, out of 130, I'm taking at least, right, 130 means 65, and then 70 active participants. So then if I want to go to the next slide, I should get an interest. 70 participants should respond, then I'll go to the next slide. So that is the concept of what any transaction that is validated need to be validated by the multiple entries, right? So here I'm taking that agenda. What is that agenda? Means minimum 70 people need to answer so that I can feel comfortable for going to the next slide. So that we call them as what? Consensus mechanism. We call them as a consensus mechanism. So these properties will make a blockchain is equal to a digital trust. A digital trust will be ensured. Now, if we observe carefully where we discuss this trust concept, in IoT, one of the key challenges is trust, right? Trust, identity, trust, security, and privacy. So, how to enable trust in this sense? Blockchain is going to provide the trust here because of the inherited properties, whatever we have in the blockchain will make the digital trust, right? Now, we'll try to discuss what is this blockchain. Now, what is this blockchain is nothing but any transaction. Now, I'm sending a question to you, you are answering. I'm sending one question means that is one transaction. You are giving answer means that is another transaction. So, all the transactions that are going to be stored, we are going to store on a ledger, in a decentralized manner. Right? No one has the exclusive ownership. I don't have any control now. You don't have any control. Now, what is happening, right? If you have a control, right, I'm going to control every people. Don't talk. That's it. So that control should not be. Because I want to distribute the control to all the people. Everyone, I want to make it responsible. So blockchain is going to provide such type of solution. No excessive ownership or control on the record or transactions. Everyone has the ownership here, right? Which you can have. Now, what do you mean by blockchain in this sense? A record or collection of record of transactions that are going to be captured on a block. Now, what is this block is? Block is nothing but transaction 1, 2, 3, and so on. We are going to capture on a block. And every block is referring to the preceding block. We are going to create a new block that is going to proceed to the previous block. And it forms a chain. That's why we call them as a block chain. Blockchain. Right. So the word why we call them as a blockchain. Now you're able to get it now. Yeah. So this block is nothing but set of transactions. Online transactions can be done, and it forms a chain. Right. If anything is being tampered here, automatically this will be changed. If anything has been changed here, it is also changes here, new transaction. So it is very difficult to tamper the things, right, using the blockchain technology. Now we have a definition here. A blockchain is nothing but a single linked chain of blocks of verified signed transactions that is going to replicate globally on a peer-to-peer network. Now we have a network is a peer-to-peer network, we are going to call them as, right? This is a peer-to-peer network which you are going to see here. Sorry, it is already connected. This is a peer-to-peer network. Now a user is going to send some transaction to on a network, and it is going to replicate it because I'm going to sign this transaction. Everyone will verify this transaction. T1. Everyone will verify this transaction. Everyone will verify this transaction. And then this transaction can send to the other T1 to the other user. So this is a peer-to-peer network, and this is a blockchain. Because these transactions we are going to store on the chain. So each and every block is linked with the hash point. So what is the advantage of this one in the sense, right? If I want to change a block, right, it will change the millions of nodes. Millions of nodes. That's why it is very difficult to connect. Right? So this is a formal definition of a blockchain. Now, if you see, this is block, and we have a hash. This block is referred to this block link, we call them as, and this block one is linked with the block, and this block is linked with the block. So this is the block, and this is the chain. We call them as a blockchain technology. Clear? You're able to follow me?
Yes, sir.
Yeah.
Yes, sir.
Right. Now, how to transfer and how to find and transfer the. Assume that user A is performed some transaction. Now, user A has asked some question to B, right? B has asked some question to C. C has asked some question to D. All these transactions we are going to call them as. C has performed some transaction. D has performed some transaction. E has performed some transaction. F has performed some transaction. All these transactions, one of the validator called, like this FDB program is a coordinator, is going to collect all the transactions into a block. And this block will be validated. This block will be validated. The node will validate that block, and then it's going to send to the chain. The node will validate the block, and it's going to send to the chain. So this is the way how a blockchain will be created. And you're getting now? Now, how the IoT uses blockchain? How IoT network like 5G network, IoT enabled 5G network uses a blockchain. Now you see here, this is the fog node. This is the fog node. This is the fog node. Like gateway. Gateway will be the fog. And all these fog nodes are going to connect it to the some centralized server, like cloud. We call them as a cloud. Now, what is the problem with this? If the cloud is not available, it's called as a single point of failure. Single point of failure we can have. So we are going to replace that that server with a blockchain. Means all this is one fog node, this is another 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 fog node, and all these fog nodes are enabled with a P2P network. P2P network, right? So this is I told you, these are the edge devices or IoT devices. This is an IoT devices we can have, right? This is an IoT devices we can have. This is an IoT devices, and these are fog devices, fog or edge devices we can have, right? And I'm going to replace with the blockchain, which we can create, right? In order to go for this one, this is the one network, and this network will be connected to a gateway. This is another network which is going to be connected, and this is another connected, and then we are going to call them as one node called, this is the edge node, edge router or a broader router, right? This is the edge device, IoT device is an edge device. This is a fog node we can call them as. Right? This network is connected to this gateway called broader router, edge router, and this is connected to this one, to the one validator, we call them as a fog. Now you see here, now this is the one network we can have. This is another network we have. This is another network. This is another network. This we call them as validator 1. This is validator 2. This is validator 3. This is a validator 4. And then we are going to create a blockchain. Now what we are going to create is a link of trust will be created. all these network devices will be known to all the three people. All these devices will be known to all the three people, all the four members, all these one. So this is called as a link of trust will be created in a blockchain. This is a way how a fog enabled a blockchain network or 5G enabled IoT network can be created to authenticate the IoT devices to provide the secure communication between the IoT devices. Okay. So this is a decentralized model we can have. We have validator 1, validator 2, validator 3, validator 4, validator 5, different types of validators will be there. All these IoT devices are going to be connected to the validators in a decentralized manner. Like this also, a blockchain can be created. Okay. I hope this that ends from here. If you have any questions, please.
Sir, I have a question. Sir, previous slide. Hello.
Which slide you want?
Just previous slide, where you have shown the validators connected to various sensor nodes.
This
Yeah.
one?
So basically, sir, what is happening? So many IoT devices are there which are actually sensors, and these sensors are transmitting the data to validators.
Mm.
Right?
Yes. Yes.
Okay. So now you are saying that between various validators, we are having the trust link, right? Trust links, whatever you are telling, trust link.
Yeah.
So meaning is that validator 2 will know the which of the IoT devices are connected to validator 1. Is it so?
Yes.
So they will be knowing about the information, that what type of information is being collected from validator 1 from various IoT devices. So all other validators are also knowing what
Yes.
type of
Yes.
information is being
Yes. Yes.
collected.
Yes.
Is it so?
Absolutely. Absolutely.
Okay, so in this way, all the validators know what is the information collected, right? So
Yes.
everyone
Yes.
knows about other. But here we want to have the security that no one should know my data,
Yeah.
what type of data I'm transmitting.
Okay. I'll give
So,
answer to you. Right. See, here we are going to maintain a blockchain to only authenticate the data. I'm not going to store the data in the blockchain. Only
okay,
the identity details and authentication details I'm going to store in onto the blockchain, not the data which is sending from the IoT devices. Like for example, right? For example, whether you have been registered for this FDP program or not, only I'll verify it. The coordinator will verify whether you have been registered or not from so and so institute or not. That after validation, then how the sessions are going on, that is a difference between that is communication is going on between the participant and faculty. Yes or no? So here also, IoT device authentication and identification only blockchain stores. It doesn't store the data which are coming from the IoT devices.
identity means the data which is being collected is from so and so IoT device. Is it like that?
No, see,
That identity we are talking, right?
no,
Not the type of the information.
we are talking about the
Hello.
address. We are talking about the identity of a particular device. Like for example,
Okay.
this is a device number 1 and it has IP address and what is the timestamp it
Something.
is
Yes.
being.
Okay.
The whole
Okay.
information we are going to store onto the chain blockchain. We are not going to store what type of data it is sending.
Okay. Okay. So, what is the advantage of knowing others' MAC address or others whatever address we are storing?
Authenticate. See what is the matter? See, for example, if this FDP is there, why I need to restrict it to only few registered people? Anyone can
Okay.
in this universe can listen. No,
Okay.
you got my point or not? We need to provide security, right? Which device is sending to which information? That because now a device A is sending some information to device B. Now
Okay.
device B is connected to validator 3. Device 1 is connected to validator 1. Now these devices have a low power devices and I cannot implement security here. On behalf of
Okay.
this node, I'm going to provide security because these devices are relying on this device. They have been relying on this. These two are relying on each other.
Okay. So, in
So
this means, okay. Yes.
yeah, what
Uh,
I'm saying here, I'm going to send the data to this. I'm going to validate this fellow. And then once the validation is happened, once authentication is happened, these two people can securely communicate it.
Okay, okay. So all the validators are saying that yes, these devices are connected to me. Second one is saying these are connected to me, and they are basically authenticated one, right?
Yes, yes,
So
yes, yes.
that's the thing we want to make sure by using this.
Yes, yes,
Okay.
yes.
And what about the secure transmission? So the security, nobody would be able to see my data. For that,
Right.
we have to do
Now,
something else,
no,
like
that's the point.
encryption and other things will be required, right?
Yeah, yeah, yeah. For that purpose, you want to use a shared key between these two things. A shared
Okay,
key will be sent. End-to-end encryption can be provided. End-to-end
okay,
decryption can be provided. These fellows will work like a trusted environment. Now, what is that? This
okay,
fellow will generate a key for on top of these nodes, and then they will
okay.
send that key will be there.
Fine, fine. Okay, sir. Thank you.
Participants, if you have any queries, you can discuss with the resource person now.
Sir, request to share the PPT, please.
Yeah, if required, I'll share to the coordinator. Coordinator can share.
Yes, sir. Okay, sir. Thank you, sir.
Yeah, Sai Kumar, you raised your hand.
Participants, if you have any doubts, you can unmute yourself and discuss with the resource person.
Sir, can I know what are the energy related issues related to this IoT, like security and energy? Are they connected?
Yes, yes. See, if you try to implement resource hungry devices, resource hungry mechanisms on IoT devices, it will consume a lot of energy. So
Yes,
try to implement. We need to have a lightweighted security mechanism need to be incorporated on the edge devices.
yes, yes.
I repeat again, participants, if you have any queries, you can discuss with the resource person now. Participants, if you have any queries, you can discuss with the resource person now. Sir, shall I conclude the session, sir?
Yeah, fine. From my side, it's good.
Okay, sir. Thank you for sharing your valuable knowledge, sir.
Roger CSC.
Thank you, sir. Thank you for sharing your valuable knowledge, sir.
Yeah, may I quit now?
Yes, sir.
Yeah, thank you very much. I thank the coordinators for inviting me. I thank all the participants for bearing me this 1.5 hour session. Right, thank you, one and all.
Thank you
Thank
very
you,
much,
sir.
sir.
Thank you, sir.